Hi everyone, I hope you're all doing really well, keeping up on your assignments. We're going to talk a little bit really quickly about annuities. I just want to make sure that you guys understand what they are and the formula we're looking at to calculate the amount. So, everyone should know at this point. If you don't, let me know. We'll talk about it in more detail. But there are retirement accounts. They're basically long-term savings accounts that you use to you invest in periodically. They earn interest, and hopefully in this long-term account you earn enough during your retirement to help support you. The most common ones you've heard of probably are 401ks and IRAs. You've maybe also heard of a Roth IRA. Those are long-term investment accounts that have a limit on how much you can contribute annually. Another type of long-term investment account is called an annuity. An annuity is very similar in that, but it does not have a limit to how much you can contribute every year. So let's really quickly take a look at the formula for savings annuities. We have, again, this is a really good little outline because it not only gives you the formula, but it breaks down what each variable is. So here we have A of T. This is the account balance of the account after T years, or A as a function of T. This equals D, which is your regular deposit amount each month, each year, however often you're contributing. And then inside of here, we have 1 plus R over N, all to the NT. Now, R is your rate, your interest rate. N is the number of times the interest is compounded annually or in 1 year. So let's say the interest is compounded monthly. That means your N would be 12. Let's say your N is compounded daily, which is not common. It would be 365. That's just an example. And then all of that is to the N times T. That's the number of times it's compounded, times T, the number of years, minus 1. That's your numerator. Down here in the denominator, we have R, your rate, divided by the number of times it's compounded in 1 year. So if you had all this information, like how much you're going to contribute annually, your rate, the number of years you plan to have this in your investment, this is a good thing. Let's say you're 20 years old and you want to retire at 60. Put a T equals 40 to get an idea of what you could earn if you started investing early on. And just for anyone who's not already investing in retirement, if you have the ability, I highly recommend it. The sooner the better, because that money just will earn you interest on top of interest. Anyway, so that is the main idea, and the idea is that the more money you earn, the more interest you get. It's a great thing to do. Let's go ahead and take a look at these examples. So we have example 1. Josie deposits $200 per month at 5%. That means that let's go ahead. I already wrote the function over here just so we could keep an eye on all these. Let me make this a little easier to see, hopefully. Okay, so here for Josie, we have D is going to equal $200, right? 200. The rate, or R, is going to equal 5%, which is equal to 0.05, right? And then how much more interest will Josie earn if she makes deposits for 40 years versus 20 years? So this is assuming the exact same account, but now we're doubling the length of time. And what you'll see, I can tell you right now, is that she's going to earn more than double that amount of money. So for anyone, again, that's not investing and you have the ability to do so, I highly recommend it. So first, let's go ahead and look at 20 years. So we have, let's look at, here's an example. Let's go ahead and look at our function. So we've got A of T. All right, so we have, let's see here. All right, we have A of T, equals, we have 200 times 1 plus, and our rate was 0.05 over 12, parentheses, all to the NT. So N is 12 times 20 years, minus 1, all over R, 0.05 over 12. So let's go ahead and just look at that numerator first and plug that into the calculator. And we get on the top 342.528. And on the bottom, we have 0.05 divided by 12. And that is 0.004167. So when we divide that, divided by we get about 82206.7. So let's go over to the other page. So we had 82206.7. Now, the one thing that we need to remember though is that Josie deposited a lot of money. So if she did $200 now, that's how much the final amount is going to be. That's after 20 years. All right, so now let's remember how much did she deposit, like total deposit amount, because we need to subtract that out, right? Because she's going to deposit less after 20 years than she will after 40 years. That means the 40-year thing, there's going to be a much higher deposit. So we need to look at the initial, that's called the total principal. Deposit or principal is going to equal, so she did $200 a month. So that's 12 each year, right? And then 20 years. So that when we do that in the calculator, we get 200 times 12 times 20 years. So 48,000 she invested. So that means that the total interest that she earned in 20 years is going to be 82206.7 subtract 48,000, which is about 34206.7. About. I think it goes one more to the there. It's just not showing on my calculator, but I just went up. Okay. So that right there is how much she makes after just 20 years. That's a lot of money to make after 20 years. Now let's see what happens after 40 years. So let's go ahead back over here. So let's just remember that number. We're going to come back over here. We're going to erase everything for the 20. And we're going to go look at 40. And we're going to write that number up there just so we've got it. So for 20 years, she would have made, or she will make, 34206.73. Okay. So now let's look at 40 years. So for 40 years, we have, again, so amount with 40 years equals, the deposit amount is still 200. We have 1 plus the rate doesn't change and the n doesn't change. Remember, because we're looking at the number of times the interest compounds every year. That's to the nt. Remember, n is also the same, so we have 12 times, but now here we have 40 years minus 1. All over, oops. We have 0.05 divided by 12. All right, so let's do that top part. Let's see if I can get that. So when I put that in the calculator, make sure I typed it in correctly. I get 1271.68, and the bottom doesn't change from the last calculation. It's 0.004167. Should I type that in correctly? I always like to double check that I type things in correctly because it's so easy to make mistakes when you're going through these. Okay, so now when we do that math, when we take this 1,271 and divide it by this, we get about 305,204.03. Okay? So now, just like we did last time, did we write that number down yet? Just like we did last time for 20 years, we now need to figure out how much we invested. So here, let's go ahead and write that number up on the second page. Sorry for going back and forth. We have 305,204.03. So that was our total amount after 40 years. So what we need to do is find out how much we invested. So the principal Sorry, this thing is very difficult to write with today. Principal is going to equal, we did 200 a month, 12 months a year, 40 years. Let's multiply that out in the calculator. 200 times 12 times 40. That is not right. 200 times 12 times 40 is $96,000 investment over 40 years. See how $200 a month can give you a lot after 40 years, just without even looking at the interest. So then we're going to look for our total interest earned is going to equal this, the total amount minus your principal. So we have 305,204.03, subtract 96,000, and we get 209,204.03. So let's bring that over here to compare. So 40, so let's look at this. 40 years, we ended up with, so this was 34,000, 209,204 and 3 cents. Do you see that difference? Over another 20 years. So you're more than doubling your money, okay? That's pretty crazy. So the original question was, how much more interest will she earn? So we need to take that and subtract out that 34,000 and change. And we get the difference. Sorry, this is getting all jumbled in here. I'm running out of room. Difference is equal to 174,997.2 or about 30. That's, so let me make that red so you can see that's the difference. Okay, that's a very, very significant amount. So like I said, this is not just a math lesson in how to calculate annuities, but also how to realize investment like sooner rather than later is always better with retirement investments. Okay, so I hope that kind of helps you guys understand what we're looking at. I know that was kind of a long example. If anybody wants a different type of example or some other type of problem, let me know. But what we did walk through was how to find the final amount, how to look at the total interest, how to look at the total principal invested, and how to compare different years. So I'm hoping this covers like a wide range of possible problems or things that might help you with them. Remember, there might be something where it says, okay, well, how long would you need to invest, or how, like what rate would you need? All you need to do then is take this problem up here and solve for it algebraically. If you have any questions about this, let me know. I will gladly walk through it. If it's a specific type of problem, please send it to me in your email. That way I can just walk through it and show you how to do it quickly without having to go back and forth. So again, I hope this helps anybody that's working on the annuities. Let me know if you have any questions.